Let's get started. Everything is so tiny up there. Make it a little bigger. Oh well. How's everyone doing today? Good? All right. Awesome. All right. Well, I don't know if you're gonna. I completely admit I don't have everyone's name down yet. I'm working better, but I don't know if you need names again to try and get a attendance count real fast, Matt.
Yeah.
Jeez. This is an area where if I was ever tested for it in school, I would have failed. Just completely and utterly failed. I got lucky. I never got the tests like memorize all 50 states. I would be like, I don't know. Sorry. Well, let me get in-person feedback because I already asked online. What do people think of the REPL.IT site so far? Has that been working well? The homework, you like it? So one question I have is, have people been having their code, has anybody's code failed when they tried to run it against the tests? I'm not saying like, did it continually fail? Did it fail at least once or something? Yeah, did you find it useful? Were the tests useful in terms of the feedback that they gave for the failure?
I mean,
Okay.
I think it could be more like they were very like.
Okay. If there's, so I'm writing those tests sort of by hand for each one, and it varies. So the more feedback that I can get on whether you think the test was useful or not, especially if you do get past it and if it helps you solve the problem, or if you're like, I'm stuck and it's failing and the test isn't really helping me figure out what's going on. Any feedback I get on that would be great because I want to build on these, make the tests as descriptive and helpful as possible to help walk people through when they're encountering issues.
Even though it's like incorrect, it was still should be out like the run output. And I like that it was actually getting so
Yeah, sometimes it's a little hard to do that. That's the way the tests, ideally what you see is here's what I expected and here's what I saw. Sometimes it's hard where I think with the arrays in particular, it's doing some weird stuff where you don't get to see what, if it's checking all the items in it, you see like, I expected, I don't know, something that looks like an empty array almost. And I expected 4 and I got like an empty array thing. So I've noticed some issues with that. I don't know if there's much I can do because that's sort of coming from the library or the code that does that check in terms of what it actually reports back. So yeah, I did notice a little bit of the fact that the messages that the tests give you aren't always the most effective. I'll do my best without putting an excessive amount of effort in to try and make them report something nice back by testing as explicitly as they can. But any other feedback on that? That's good feedback. All right. So I threw up the notes. Today is going to be that want to review functions again and just go over that a fair bit. And then, so I don't have any, throw up like the scratch.md file because I don't have any big stuff. I'm going to go over functions. We're going to talk about debugging, and I'm going to show you 2 different tools that can help you with some of that. This may help you visualize your code and understand what's actually happening when your code runs, trying out these debugging tools that help you do some of that. So I'm going to show you a little bit of that. These are really complex and powerful tools because they also, depending on the tool, show all of the stuff going on behind the scenes that you don't realize is happening in your programming language. So they can also be a little overwhelming. I want to talk about some syntactic sugar. And what I mean by that is we're going to take at least one thing that we've been writing a lot of. We've been writing a lot of loops, and we're using a while loop. I'm going to show you a nice, simpler way to write a good number of while loops, not all of them, but it's an easier way to write a lot of them. And this is sort of a term that you'll see used in programming, where syntactic sugar just means we're taking something that you already have to do and we're making it a little easier. It's sweeter, it's easier, hence the sugar term, I guess. And then at the end, we won't get into coding specifically on them, but I want to talk a little bit about objects and send you off with just one small homework assignment that's more hands-on, less writing code, to start getting in the mindset of thinking about objects and how they work, because that should be the topic that we really dive into next. Any questions so far? All right, let's talk about functions. Does anybody remember what we discussed? How do we, what is the purpose of a function in a programming language? What does it do? It's a tough one. Let me ask you this. Let's step out of our programming language again. What's a mathematical function? What's the purpose of a math function? To output a value? That's, yeah. You know, I'll just throw notes up here, right? Any other thoughts? Purpose of a math function or a programming, a code function?
So that we can use it multiple times.
Use it multiple times? Yeah, it's an important aspect of being able to work with a function. Any other thoughts or descriptions? Perform a task. That's very much, I would say that's much more confined to the aspect of a programming function than it is a mathematical function. Although you could say that that's what a math function does, but let me throw a couple others up there and let's just see what you guys think. Another way you might describe it is takes some input and returns an output, maybe, or potentially transforms some input into some input value, and I'll put an S there, maybe there's multiple values, into an output value. Those might be a couple other ways to describe a function. I think one of the key ones here in terms of the way that they're going to work and to help break some of the just concrete thinking is I like this, use it multiple times, because it sort of breaks reading your program flow from top to bottom by writing a function. Instead of going top to bottom, you're putting a little bit of code somewhere that you say, just remember this little bit of code over here because I want to come back and use this somewhere else, but I'm not using it right now. I'm not going to use it where I write it. So when the program reads top to bottom, it sees it and it says, okay, I know that that exists and I can use it, but I don't have to do it immediately. See if I can come up with a good real world analogy for something like that. I mean, it's almost like, you know, any appliance you would have in your kitchen, right? You've got a toaster, and your toaster, you know, takes bread and turns it into toast. Whatever brilliant genius thought of cooking bread a second time, I thank them very much. Toast is delicious. But that's very similar to a function in the sense that you don't I know it's sort of weird to put this in a real world analogy. I'm just trying to show you how it operates very similarly. Is you don't have to, it's not like you buy a toaster and it's used immediately and then you're done with it. It's a utility, something that you're storing, and then you can pull out and use at any point in time when you want to use it. And that's the same way that a function works in a programming language for the most part, is it's this nice thing that you've stored off that you can come back and reuse over and over again if you need to. Somebody remember what the JavaScript keyword is that we use to start a function when we're doing a function declaration? Var? Var is usually what you use to assign, that's creating a variable. So function is the keyword. Now there is a way, I won't get into it right now, to use vars to work with functions. I'm gonna skip over that and maybe come back to it probably in the next, like the intermediate type class, where we're just teaching a lot more of that syntactic sugar or other nice things. So use the function keyword to declare a function. And then you have to give it a name. At least you have to, unless you can assign a function to a variable. We just haven't done it yet. So you can assign like function add, and I don't even actually have to give it a name here. I'm not going to do that right now, though. I'm just showing you that something like that is possible. We're just going to declare it directly. So this, you can almost think of this like the variable name, because it sort of lives in that same space. And maybe I'll show you why it makes sense to think of it like that in a moment. But if we've declared an add function, you know what, I'm going to make it the simplest one I can. I'm going to say hello instead. Let's make it a hello function. And inside of it, we'll do what we've always done. We'll say hello. By the way, there were some very creative, for the people who have already done this on the homework, creative hellos that people had in there, what's up, or other things. So I like reading through some of those. Greetings. I don't know. Say this is some sort of, what's a good hello here? These are aliens. I don't know. We come in peace. That's what they're saying instead of just normal. Because we'll have some fun with it, right? And then if you want to use this function, if you want to invoke it and utilize it, you can do that. And the way you do it is by typing out the name of it and putting a couple parentheses after it. So if I were to run this now, let me see here. Nice, I got the keyboard command right the first time. What we should get is just this printed out. There's not a lot going on here, but it's useful to understand the order of how this happened. So I'm going to put another, again, this is very similar to what we've already done, but I'm going to put another console log here. And then we'll run this. It's very useful to notice that the first printed message got printed before we come in peace. And that's because even though this code existed up here, this line actually wasn't run, because it's like the toaster. This is like us putting toast in it and getting back something on the other side, right? So we've just stored it. We've basically built a little toaster in my earlier analogy, and then this is us using it at that point. And we can do it over and over if we want. You can say hi as many times as you want to. Boom, boom, boom. Nothing too much going on. Now, to sort of show you that this function this is gonna be a little weird. Does it say function when I do this? I don't know what's gonna happen here. We're gonna find out. So in this case, when I put the parentheses after it, that's me invoking it and running the code inside of it. But I can refer to it just like I would a variable as well. So here, I'm gonna log out the type of hello. And get rid of my couple extra prints so that it's a little easier. And you'll notice what it printed out was, it says it's a function. And that's because in that case, without the parentheses, I'm not saying run this code. I'm just saying what is hello, this essentially variable. And in that case, well, it's a function. But here, when I put the parentheses on it, I'm saying, oh, run the code and run this function, as opposed to just look at the function. Does that make sense? The difference between executing it versus just pointing at what it is? And now that you've seen this, you begin to see why I said this is a lot like just sort of giving it a variable name. So if we tried to do something here like hello equals, I don't know, this one's more classic, good morning. Let's, anyone have a guess as to what's going to happen? You can talk with each other if you want to for a second. Try and guess what you think is going to happen in this bit of code. Type of is going to become a string. All right. What do you think is going to happen with that hello call below it? All right. So the guesses are type of is going to become a string. So we're going to see first printed message, then string, and then we come in peace. See what happens. And we blew up. But let me scroll up for a second. Let's see. First printed message and string. So we were right up to that point. And then hello is not a function. So that gets to what I was saying is this is very much like declaring a variable named hello. It's almost the same thing. And it's so similar that when we down here declare a variable and call it hello, we no longer have access to this function because that name now is bound to this string instead of being bound to this function. We've sort of broken our language in that context. So it's just a useful thing to know. You can't name a variable the same thing as a function name within the same scope. Again, we'll talk more about scope going forward, but they can't have that same name. And we're back to working. We're all good. It tells you it's a type of function, but again, this is the type of operator line because function is not actually a type. So thank you. Type of operator. Any questions on what we're seeing right here? Come over function again. All right. Who remembers how do I declare parameters to a function? Put something in the parentheses. Yeah. This is essentially creating some variables that will exist only inside of our function. So I'm going to change this. We're not hello. Create an add function. An add needs two variables. What do we want to call them? A and B. That's fine. All right. So in this context, A and B, and we're going to see, I'm going to go over all of this again inside of the debugger, which I think is going to help out as I sort of show debugging, but I want to show it here first. And then hopefully by going through some of this stuff in the debugger to help click what's actually going on a little bit. So if we've got A and B as these parameters, that means essentially we have an A and B variable that exists inside of this function and we can do something with it. And if I want to, I could do like console.log A plus B, which is going to print out A plus B when I call this function. So if I add 3 and 5 here, and if I call this, we'll see it print out 8. But one thing that's going to happen in this case is the returned value from our function because we didn't explicitly return anything, if I log this, is undefined. So that's something you could do, but I'm pointing it out because this is probably one of the first mistakes that a lot of people make when they start working with functions in a lot of the homework and when they encounter it, is they're used to console logging to see the results of something. And so they'll write their function, and then inside of their function, when it says return a value, instead of returning a value, they'll console log and then not realize why their function is failing and not doing what it says. So the key to actually return a value is using the return keyword. And if we look at this, we'll get a different output now. Oops, I screwed that up. Let's come back down here. And now the only thing output was 8. And that's because we didn't have a console log in here, but we did still log our return value. So we got back out of this function the value that we passed into it. And this is where it starts to, let me write an example that begins to show why it's useful to work with return values instead of doing something like just a console log, is because now once you return values, you can start using that to build your program up over time. So let's say I want to get the return value from this. I'm going to log it, and then I'm going to call this function again, and I'm going to pass the return value in as the first argument, and I don't know, 13 is the second one. And then let me log the result of that so we can see it down here. We get 8 and 21. But if I wasn't actually returning a value from add, if instead I was logging inside of that function, it makes it something that I can't reuse and build up with. It's something that you can call in, it spits something to the screen, but I can't actually use the value back from it to build a program into something that's composed of other pieces. So that's one of the primary reasons that working with return values provides so much more value as opposed to just doing something inside of the function, is it lets you compose stuff. Whereas if you're doing all that work inside of the function, it's harder to use that to compose something together. Does that make sense? All right, let me see if there's any fundamental concepts I'm missing with functions. There's a few little tricky things that we covered in the last class. One thing to remember when you're reading any documentation is up here on this function declaration line, these are called parameters. You can even see it sort of right there as you hover over it. This is a parameter. Here, when you call a function, these are known as arguments. So you pass arguments into a function when you invoke it. But these are the parameters of the function up here. They're not called arguments. So if you're reading any documentation about how a function works, you'll usually see parameters as the documentation. It takes these parameters. All right. How are we feeling so far? Good with the functions? We'll look at this stuff from a different perspective in just a minute too. Delete all that. Okay. I am going to now try and show you, and I haven't worked with this, I'm going to try and show you how to do some debugging or use debugging tools a little bit to help you understand code. It'll also help you if you run into a bug in some code. So in honor of today, I've taken our standard program that prints out a list of something, and I've converted it to print out different types of pie because it's Pi Day. And so what we're going to do here is a little different than what we've done, and I'm going to run this in 2 different contexts. I want to get some feedback from you as well as to which one you think was clearer, but you could use either one of these when you are working with code. I'm going to run it inside of Cloud9 and show you how stuff works here. And then we'll run it in another thing that's intended to help visualize how code works. So if I just run this right now, and I'm going to use the run button. Yes. Oh, sure. Yeah. You want me to read through the code? So what's going on here? This is pretty just name changes of some stuff that we've done before for the most part. I created a variable named varieties, which holds an array of strings, and these are pi, types of pi. Then I log, the code logs, just something to start with, saying like popular types of pi include. And then we do the 3 steps of any loop in here, which is we initialize our loop, or most loops at least. We initialize a variable so that we're ready. We do our conditional check of, do we need to keep going through our loop? And then we have our bit that increments our loop. And I put those 3 together and sort of skipped over what was in the middle because that's just looking at, those are all related to the loop and how we do loop logic. And then internally what we're doing is just logging out each string and concatenating the string of space pi after it so that we end up printing out what we have down here, which is popular types of pie include apple pie, pumpkin pie, cherry pie, rhubarb pie, pecan pie, peanut butter pie. Am I missing anyone's favorite? No? Oh, I was missing someone's favorite. I think someone. What? Pumpkin? All right. What? Cheesecake? Is that a pie? It literally has cake in the name. Oh my goodness. This is like the what's a sandwich debate. I personally prefer the what's a salad debate over what's a sandwich. What makes a salad, right? Because there's like fruit salad that doesn't have any like lettuce in it. And there's like potato salad. So I tend to think a salad is just, it's just a combination variety of foods put together. So I started referring to my ice cream sundaes as an ice cream salad, so I feel a little better when I eat them. So I don't know. Yeah, see? It's all in how you name it. It's all in how you name it. Okay, we feel good now reading through it? Okay. So let me try this again. I'm gonna run it. And what we should see is it just goes ahead and prints out our stuff. No problem. But there's actually an ability, if you're using this run capability, which it has right there, if you come over here in your code, you can actually set a breakpoint. There's another way to do it as well. I don't know if it works in here. I'll try it in a minute. But there's a keyword called break that works in Chrome at least. It might work here, which literally is the same thing. It's just explicitly setting a breakpoint inside of your code. But I'm going to set one right here. And now we're going to run the code just like we did before. And we're going to see something different. First, we see this whole panel pop in from the right-hand side here on Cloud 9. This is where I was saying there's a lot of complexity in this that you don't necessarily need to know about right now. But it's telling you a lot about what's going on in your code. And you'll notice also we've got a yellow line here, sort of highlighted, and an arrow pointing at it. And if we look down here at what's printed out, nothing has printed out yet. That's because the code, like the execution of this code, is literally stopped right here on this line. And it hasn't run that line of code yet. So it's just waiting for us to tell it to do something. If you want to, you can come over here and sort of play with this stuff, look at these variables. There's a lot of stuff in there that's very complex about how this environment works behind the scenes that you don't need to know the details of just yet. But one useful thing you can do inside of here is you can sort of hover over the variables and see a little bit about them. And it'll make a lot more sense in a minute because this, for whatever reason, in Cloud 9, it looks like an array and only shows you this empty array bit. But these are the key parts when you're debugging your code, are these little controls here. So this one here says just resume, keep running the code. So I'll click that first. And what you'll see is it ran through all of our code. It finished running the code. Okay, that's fine. Now I'm gonna rerun this. And this time, instead of resume, I'm going to use these step functions. And this is how we can step through our code line by line. So I'm going to take a step, and it just launched me into a whole nother file. What is going on? This is actually the code behind that console log and what's actually going on with it. So you could dig into this. It's a whole bunch of complex code, what's going on down in here. I don't want to know what's going on there, so I did this one, which says step back up. Like, get out of that context back to where I was. And then I'm going to use instead this step over. And when I click that, you'll notice that my arrow now points to the next line of code. And we've printed out what was on the previous line, the console log. So it's finished executing that line of code. And now if we look here, what's interesting is we haven't run this line of code yet. So index is undefined. And that's because we haven't assigned a value into it yet. This line of code hasn't run. So if I step over this the same way, and I come back up here now and look at what index is, it shows me 0. It's a little hard to see on here. But you can actually see that index has a value of 0 right now. And that's because at this point in the code where we are, we've assigned a value to it. And we can also look at varieties.length and see that its value is 6. So I'm going to step over that and then step over this console log, because I don't want to go down into the details of it again. And we'll see that we've printed out apple pie. And now we're on this index ++ line, which still has a value of 0. So let me step over that, and if we come back up here now, or look at index, now we have a value of 1, because we just incremented it. And you can have more than one breakpoint, so I'm going to set one right here. You can even do it while your code's running, assuming you haven't passed that point in the code. And since we're going to come back to this, you can see every time I click this run button, it'll run until it hits another breakpoint. So when I click it again, it runs one more time through the loop. And I click it again, it runs one more time through the loop. And at any point in time, I can come over here and see what these values are. And in this case, the only value changing is index. But you can get a feel for exactly where you are. So now we've printed out peanut butter pie. If we look at our index, it's 5. Our length is 6. So I'm going to use this step here. Now our index is 6. And we exit our loop, and the code's done running. And I don't know, there's some other gibberish going on in the background there that I don't care about. So this is a really, really useful tool. You don't have to understand all of the details of what's going on in it right now, because you can do all sorts of powerful stuff in the debugging tool. But it's really useful for you to get an understanding of what's going on while your code's running, where you can stop it with these breakpoints and sort of take a look at your code and see what's happening. Now let me show you a different visualization of it that's a little more explicit in what it's doing. And I can post a link to this page as well, but we're going to have to cut and paste our code over into it because it's an entirely separate tool. And this was originally created for the programming language Python, but they have it for other languages as well. So it's this Python tutor website. Again, I can post a link in a little while, but we'll put our code into their tool, and we're going to do this visualize execution button in here. So you'll see it's going to take a little while, and it's going to spin up this context for us, which is going to show us some information about what's going on in our code at every point in time. So right now, if we look over here, it says, oh, in the global frame, you might replace frame with scope, because I've been talking about scope. In the global scope, we've got 2 variables, varieties and index, but they're both undefined because we haven't actually put anything into them yet. This one uses a little red arrow to point to the line of code that it's on. And down here, the controls let you step. And you'll notice actually here, it even knows how many steps to take because it already analyzed our code and figured out how many steps it's going to take to finish running it. So we can step forward line by line. Now we get, this is some of the really nice things that this one gives you, at least in a way that I think is a little easier to understand. now that we've assigned a value into varieties, if we look over here, we've got our global frame and it says varieties, and then it points over here to this array saying, here's what's in there, with a number over each spot, telling you what the index is for that, and sort of visualizing what this is. Oh, this varieties, that's an array of all these items. It points to this information. If we step one more line forward, we've printed our output here that we expected. Index is undefined because we still haven't run that line. And if we do one more, now we've added index 0 over here into the information being shown. And you can sort of step through the code line by line the same way, and you'll see it's updating the information as you run it. So this can be a really useful visualization tool as well. And one of the nice things about this one, which you don't get in the Node debugger, is if you stepped forward and you're like, oh, I want to go back because I forgot what was going on there, you can actually rewind it back through the steps to try and relook at the state at that point in time. Or you can jump all the way to the end or all the way to the beginning. Now, there's some other clutter on the page, you know, it's a little bit of a busy page, but I do think it's useful. I haven't really used it myself before, so I'm just getting experience with this sort of at the same time as you guys. I would love to get feedback on the two different ways of sort of stepping through your code and getting a feel for it. If you guys try them out in some of your stuff, practice it. Let me know if you think one of them is just much easier to work with or much more intuitive in terms of what it presents to you. That'd be great to know. This one hides all that complexity going on behind the scenes. It didn't dive down into the actual code behind like console log, which is one of the nice things about it, I guess. But it is outside of the environment that you're coding in, so it takes more work to use it. So any questions on just debugging these inside of a debugger or something that steps through? Yeah.
I wonder if we can go through that add, the program where you go to the function add with that debugger.
Yep.
There's no console log. And it would be useful to, I don't know about you guys, but like I would barely ever write like either a log or print to the console in my programs that usually debugger to figure out what's going on. So it would be useful to run through that adding program to see what's going on there as opposed to
I will. Yeah. I'm going to start with the sort of simple basic hello, and then I'm going to switch this over to a return instead, and then I'll switch over to the add so we can get a feel for what's going on in all those contexts, sort of building up the complexity piece by piece. Oh, I want to save that. Okay. So let's try a basic function in here so we can get a feel for what's going on in this code. And when I clicked to run this code, is there anything you guys notice that seems a little off immediately? A little weird? The arrow's at the end? Yeah, it's at line 5 already, right? What is going on there? That's because, like I said about the function, basically it did evaluate this code. It looked at it and sort of computed how to work with that, but then it just stored that off. It didn't run any of this code directly. So the first line of code here that it needs to directly run is this hello. Yes?
So let's say if we did like the function add with A and B.
Yeah.
Start at hello or add and then go back to that.
We'll see that in a moment. We'll see what will happen with add and where we'll start in just a moment. I actually don't know what this will do. I mean, I haven't used this tool very much, and so it's trying to simplify some things. But this is, in this case, this is the way the code works, is the first line that actually gets executed is this hello. These other lines have been evaluated and sort of stored off and saved. Okay, I know that that's there, but it hasn't been executed. It hasn't been run yet. But you'll also notice, even though this is the first line we're executing, we have a variable here in our global frame which points to this function. It says, oh, here's what hello points to, right? That's what I have. And if we step forward, we now jumped into this hello function. And you'll notice this is a little hard to see, but the global frame isn't highlighted anymore. It's highlighting hello, which doesn't have any variables inside of it. So there's not much there to see. We'll change that in a second, and maybe it'll show a little more. And now it ran that, and it tells us our return value is undefined because we didn't return anything. And we came back here, and we're done. So let's go back and edit this, change how it works a tiny bit. We're going to take this and put it into a variable right here instead of, and then print it out. And we'll visualize this guy. And again, we start here at the bottom because we're not running any of the code inside of our hello block. It jumps immediately down here to the first line it'll execute. And now we're inside of hello, and we've got this whole other frame where, again, you could think of it as scope. That's a term that's more common in JavaScript. They're relatively interchangeable, frame, scope. Just tend to be used in different programming languages for the most part. They have maybe slightly different contexts, but not much. Not enough that it should matter yet for you guys. But our greeting is undefined, and that's because we haven't run this line yet. If we step forward, now greeting has a value. And now we've printed it out. It has a return value of undefined, and we'll step back up. And you notice we've lost that other frame. That other frame isn't there anymore. All we have is our global frame, and our program's terminated. Hoping this is helping to visualize what's going on in the code. I don't know what would happen in this. This is a tool that somebody's built on top of a programming language, and so it's doing a lot of pre-analysis to figure out what to do. You notice, as I said, it tells you how many steps there are at the bottom. That's because they're analyzing this code before they actually produce that thing. So I'm guessing it's going to like yell at me. It gave me like a syntax error because of the problem. But that's really dependent on what they choose to do in this environment. That's different than, if you did that same thing in Cloud 9, it will also show you some sort of error within the tool, but it'll be very different as to what it shows you. Let me see here. So that shows me an error too, but it's still different. And here you would have to, for example, let me see. If I run that, you'll see that it gave a syntax error internally. But that's going to be, this one doesn't guarantee, I wouldn't guarantee what the behavior would be because they're trying to build something on top of it that can do a lot of analysis, and that's going to be a challenge. So let's also show what happens here if we made this mistake. We're going to go ahead and reassign hello. And try and run this code. See what happens. Oh, it tells me I just fixed the following error. Interesting. close that, I don't care. You'll see right now, hello points to the function, the body of the function. But once I've run this next line in this global scope, I have nothing now that points to this function. I've lost my access to the function, and that's because I assigned hello to a string, and now it no longer knows what the function is. So that's the problem with that version of the code when we did that. That's why you can't use the same variable name in that context. So now let's go with the one that's a little more complex. Oh wait, I was gonna do hello one more way. Hold on. Let me do hello one more way first too. I agree, I usually am not gonna have a console log. It's much more common in my code to use a debugger or some other tool to help me find the issue. And so usually my code is going to be very input-output based, a function. That console log, as I've said it before, is what's known as a side effect in your function. It's your function doing something, changing your system in a way other than just taking some input and returning a value. And so the way it's changing your system is it's writing something to the screen somewhere. At some point you have to have stuff that does that, but the more of your code that you can have that doesn't change the system outside of itself, the easier it's going to be to work with in the long run. So in this case, we're going to return a value, and I could put it right into a variable. I guess I will because it's going to show some more steps in the debugger. And I'm even going to use this variable name to try and help show you the different scopes a little bit. Now, if we visualize this execution, what you'll see here is in this global scope, global frame, we've got hello, which points to our function, and greeting, which is undefined because we haven't put anything in it. Now we're going to step forward, and we're in this hello function, and this has its own greeting variable that's undefined. This one now has the string we come in peace in its variable, but that didn't change our global frame greeting at all. The global frame greeting still is undefined. And then we're just going to return that. It gives us our nice return value now instead of what we had before. And now the greeting in the global frame is we come in peace. And that's because it got whatever the return value was from our code up here, and then we run console.log. Any questions on that? No? All right. So let's do the add. Then we might take just, after we do some add in here, we might take a break for just a few minutes, and then we can come back and talk about some syntactic sugar, easier ways to write things that we've already done. So let's put our add function in here. Does anybody remember what we did inside of our add function? Return A plus B, right? So let's call this a few times. Add 3.5, result equals add result, and let's just do some. You know what? I'm gonna do it this way, and then I'm gonna do something to mess with people. Let me print this out in between. Yes.
So last time you said the variable to return value, now you said it to result. That does not matter. It's just you're giving it a name.
I'm just giving it a name. Whatever name I want to give it that makes sense, right? I could call this sum, because maybe that's a meaningful name to me. It's whatever name is going to have meaning in my context. So result is probably not the best one because it's generic, right? It's better to give it a more concrete name than result, something that tells you something about, oh, this is probably the sum of this, you know, mathematical equation. So we look at the code here and we step through it step by step. Here we've got our function. Add is a pointer to this function logic. Sum has nothing in it currently.
What do you do that? We actually just ask what everyone expects the result.
That's a good question. What do you, yeah, let's say after we've run this line, what do you think is going to exist in the global scope? So you think 8 will exist in the global scope? Well, first thing is it jumped into add, right? So it hasn't finished that line. It's still in the process of evaluating that line. And you notice here, inside of add, it has 2 variables, A and B. And that's because we passed those in as arguments when we called it. That make sense? Like, basically assigning some local variables into it. Now it says, oh, the return value is 8. We returned, and our global frame has add still pointing to the same function, and a sum with a value of 8. If we run the next line,
Yeah, but what do you expect to happen?
undefined.
There's actually a bug in this program.
Oh, it's a good point. Yeah, I totally missed it.
Everyone see that? So like you change the variable called result to sum, and that's a very common mistake. In the next line, you forgot to change it again. So you'll do that all the time. You can practically guarantee it.
Yeah.
You change a variable name somewhere and then forget to change it where else in the code, and program the other. Perfect example.
That is that's a great example. I totally 100% missed this. This was not intentional, right?
So where should you change it?
So if we see me run this line, what we'll see is not what you think. You're thinking it's going to print out 8, but instead it says result is not defined. It's an error because it tried to read a variable result that doesn't exist. So when I changed the name here, where I declared it, I had to change it everywhere it was being used. So I missed changing it in all these other places. And so I was trying to refer to a variable that didn't exist anymore. Yeah, that was very good. It's a good example and completely accidental. Look, it's telling me, help us out. We helped you fix a bug. All right, let's step through this, see what happens. Let's see if it works correctly now. Yay! Look at how smart their code was. Their code before didn't even have this print output window because they knew I was going to have the bug. I wondered why that wasn't showing up. I was like, why isn't my print output window there? They knew. They knew I screwed up. They're smarter than me. All right, so we print this out. We get 8. Now what's going to happen after we finish running this line? We'll have 15 in sum. We go back up in here, and now A and B changed because we can call it with different values. That works just fine. We're returning 15. We assign 15 in the sum, and we print it out. So did that make sense? For the most part, still a little bit of confusion, but it helped clarify a fair bit about what's going on in the code. Was it, let me just ask, just quick show of hands, was it helpful to step through it that way? Yeah? Okay. So I mean, I really encourage you to try out tools like this. Again, I'll post a link to this after class. And maybe there's probably a good video of stepping through and debugging JavaScript in Cloud9, I'm guessing. You can do the same thing inside of the browser as well. It's even more powerful, although it will also hide some things. But let's just, I'll focus on these two right now. We can talk about debugging inside of the browser in another class, sort of show you how to do it there. But the tooling is very similar between how each one of these different debuggers work. So if you're really wondering what's going on in your code, how does it work? Why is it not working the way I expect? This is another thing you can do, right? We've shown you using like console logs as a common way to help you debug, but you can fire up the debugger, set some breakpoints, or if the code is simple enough, you might be able to put it in something like this JavaScript tutor tool and run it and see where your bug is step by step. All right, let's take just a couple minutes break if people need to. If not, we can keep going, and then we'll just talk a little bit about some syntactic sugar on some of the stuff that we've done. I'll give you guys a little bit of a just hands-on more assignment, less programming to get you thinking about objects, and then we'll get out of here. I'm just in a quick 10 minutes. Was I the only one who realized it was Pi Day? It's March 14th. What? There you go. Oh yeah, I forgot I was going to rewrite that add to instead concatenate strings and just do digits of pi, 3.141592. I don't know many more. I think it's 6 is next. My younger sister can recite 100 digits of pi. Don't ask me why. 1.5. 1.6 if you round. 1.6 if you round, yes. 3.141592.6? I don't know. Maybe I should try and learn one new digit a day. That would be a good strategy. There, I mean, just learning. There's zero use for it whatsoever. A parlor trick to do something silly. Most of my skills are useless. I learned how to juggle. Useless. I'm learning card tricks, and not because I want to do any magic tricks. No, just because a deck of cards is fun to fiddle with when you're bored. I tie my shoes in one movement instead of like 2, like most people. Useless little. One. Yeah. Which means faster. Yeah. See, it's like this. It's like let me see. I gotta get my shoe ready. It's like the one movement shoe tie instead of the 2 movement shoe tie. It takes time. No, it's just for show. All right. Let's make our code easier. Let's make you guys hate me for having you written so many while loops when you could have done stuff in a simpler fashion. what I have here. I'm going to take my pie example. And just because I prefer working over here and just thinks it gives me more space, we're gonna move it over here, put it in the scratch file here, make sure that it runs. We run, yes, awesome. So if we have this bit of code, what are the 3 things that we've been doing in pretty much every single loop that we've written? It doesn't have to be inside of the loop. It's just part of the loop logic. It could live outside of the loop itself. A counter, yeah. What are the, if we were to break it down, what are the 3 things that we do that are part of, they don't have to be inside of it, but are part of every loop that we've written so far? Every bit of like while loop. What are the 3 things that are pretty much common between them? What? Incrementing. Yep. I'm missing the part that's really core to the while. It's sort of the condition, right? I'm going to change the order of these real fast. And I'm going to rename them just a little bit, put these in parentheses, go with names that are just a little more common. But you frequently see them called, what's the first one I'm looking for here? I'm losing my term here. I call it called setup, but that wasn't the word I was looking for. Condition works just fine. And then this one I'm just going to make a little more generic. I want setup. I lost my terms here. Oh, I know what I wanted. Initialize is what I was looking for. I'll go with increment. I'll just stick with that, even though there's a more generic term, because most of the time you're doing something like that, right? So we've got these 3 steps. We've got our initialize that we're doing. That's typically been right here, our var. Then we've got our conditional check. That's inside of this while loop portion. And then we have our increment where we're changing our condition so that we know that we'll eventually exit, right? Well, those pretty much always go together in your code when you're doing a loop similar to this. So we've created, as programmers a long time ago, a nice little bit of syntactic sugar over the while loop, which is known as a for loop instead. And it puts all 3 of these bits of logic together and pulls them out of your loop so that the inside of your loop logic gets to be just what you want to do each time. And it puts these little bits of setup or stuff about the loop all in one place. So what I'm going to do is rewrite this while loop here. I'm going to comment this guy out and rewrite his logic using a for loop. And there's a little bit of this that you just sort of have to memorize, right? For with the parentheses, that looks just like while. And the only thing I really want here inside of it is the actual logic about my program. I don't want any of the condition logic. I just want what I want to do each time through it in here. So inside of these parentheses here is where we're going to shove all of that loop logic now. The first thing that you do, there's 3 bits to it that you put just right next to each other. I'm going to initialize a variable. And you could, I think you can even put these on separate lines, but just by convention, they're all sort of put together like this. Then we're going to put our conditional check, which is the same as what we had before. And then what's our third part? Index plus plus. And if we run this guy, we should get the exact same output. But what we've done is condense all of this loop logic into one line here instead of having it spread out in the program on different places. But it's doing exactly the same thing as the while loop was doing. It initializes this, it steps through it bit by bit, it increments it, and we can see that if we take all this code and say, went over here, and visualize this execution, we should be able to see the same type of thing going on. All right, we've stepped through the varieties, so now we have it pointing at the array. We log this first thing. And after we step here, now one thing is we've got the same thing. We have an index at 0 now. And you'll notice that when I step forward, it didn't actually move off of this line. That's because it has 3 things to evaluate on this line. It's 1, 2, 3, except this one gets run at the very end. So next it's going to check the condition and then step in. Now it runs the console log, runs that last bit of that line. Now our index is incremented. You notice it didn't increment until we ran that, and now it's back to running through the line the same sort of way. So that hopefully emphasizes, this is just a nice little bit of, all this did, this for loop here, is condense all of this loop logic into one place so that we didn't have to spread it out from the while loop. But it's actually doing the same thing. Does that make sense? Anyone really puzzled by that? People angry that they've been writing their while logic all spread out now? What?
It's going to be easier.
This way is what?
It's going to be easier.
With for? Or with while?
More.
With for? It's definitely easier, yeah. I try to, the reason I go with the while is because that's actually the core logic of all of it. This is exactly what I said. This is just some syntactic sugar. And after you've written out the initialization and the conditional check and changing your condition enough times, then it makes sense to put them all together because now you really get that these are separate steps and where they're happening. But I don't want people to get too comfortable with just writing all at once because that's all. There's a lot going on in this line of code. If we introduce this first, there could be a lot of confusion over everything going on. With the while loop, at least you're stepping through line by line. It's easier to realize what's happening on each line. So let me see here. That was the first little bit of syntactic sugar I was going to show you. Go ahead and speak up if there's any questions about how this works, or there's other even simpler ways to iterate over certain things that we'll come back to again, and you'll see those and you'll say, well, that's even easier than the for loop. I don't have any of that logic about stepping through it. It's all sort of hidden away from me. And it's really nice, but it's a lot nicer for you guys to sort of begin to understand how this stuff works. Or at least start here. All right, let's do one more bit of syntactic sugar today that is just a nice little bit of sugar. And this one's a little more complex, so don't get weirded out if you don't fully understand it right now. Feel free to go read up on it online. And there are some edge cases that make it different, but I'll show you what's known as a switch case statement as a little bit of syntactic sugar to make a complex set of conditions a little easier. So let me think of, I mean, FizzBuzz maybe will fit into this context if it's written correctly. So let's try that. First, I'm going to use my nice little bit of syntactic sugar that we already learned for the for loop. We're going to do index equals 0, index is less than or equal to 100 because I want to go all the way there, and then increment it. Let me just change this. I'm going to change my variable name. I'm going to use a cool trick here known as multiple cursor. Change all of them at once. That's magic. That's newer editors support this, and it's really nice. In Visual Studio Code, the way you do it is once you selected something, then if you do Command D or Control D, it'll select the next instance of it every time. And so if you do that enough, you get all of them, and then you can edit all of them together. There's other ways to do it that are easier than that. I haven't learned the better shortcuts. So, but yes, it's magic. So I've set this up. Let's just, again, building up code piece by piece, right? Make sure we're working. Most basic level. All right, I printed stuff out. Yay. And now we had our logic before, which was if number is divisible by 5 and number is divisible by 3, then log fizzbuzz, else if number is divisible by 3, number mod 3. Oh, I did sort of shorten this, didn't I? There's a little bit of a trick I did there too that maybe we'll come back and look at in a second. Else if number is divisible by 3, print is else if number is divisible by 5, print buzz, otherwise delete this, indent here, print this, right? So let's see if this works. My fingers. I think it's working. All right. So while I'm showing little bits of syntactic sugar, these are things that you don't necessarily have to use. You can write code without them. I'll go back and show you what I just did here, which if you remember that in JavaScript, values, anything that you put into a conditional bit of logic, evaluates to truthy or falsy. And 0 evaluates, let me double check this here. Let me see if this is going to work first. I think it will. I could be wrong. Oh, I have it backwards. So I need to do a not here to get it correct. So if I did a not there, then it would be like saying essentially not falsy, because if this is divisible by 5, you're going to get 0 out. Since 0 is falsy, I would want the opposite of it. I'm not going to write it that way. I'll leave it this way. So another way we could write this instead is using a switch statement. And in this case, we're not getting a ton of, it might actually even be more lines of code that we end up writing. But there's definitely cases where it's really handy to do a switch statement instead. So I'll introduce it as a bit of syntactic sugar, and it can at least make it sometimes a little easier to read. It's got some gotchas though as well. So I'm going to take this logic, comment it out for now, and instead we're going to do a switch. Again, don't worry too much if you don't have the syntax for this perfectly right now, or feel free to go read up on it. You don't actually run into this a lot of times in code. Some people will even say switch statements are bad code or a sign that your code isn't well structured, because you're putting a whole bunch of conditions in one bit of code. It makes it hard to know what's going to happen. But the way you do this is you say, I'm going to switch on something about number, and then you give it different cases. This is a little bit like the if. So the case here is going to be number mod 5 equals 0 and number mod 3 equals 0. And I totally am going to have the syntax wrong here because I don't write switch case statements hardly ever. So I'm actually going to have to look this up because I know I've got something wrong with this right now. Okay, here's the value, then I put a colon after it. This is why it's strange. It uses a different syntax than just about anything else in the language. Makes it a little hard to work with. So what I'm going to do now is put FizzBuzz here. And just test this code after I have this one little bit of logic in here and nothing else, and it already isn't working. So let me see here. I don't know, I may not actually be able to put a conditional inside of it this way. It may just check against, oh, the expression. Oh, I may not be able to write it this way. So I may have introduced something that's not going to work. I'll give you a different example instead that'll be easier. Let me see. Yeah, I can't. I have to put the expression up there. It doesn't evaluate each line. It can only be a direct value. So let's change this a little bit. Let's not do FizzBuzz. Let's go back to, we did the taxes example, right? Where there's different taxes for different types of goods. So what I'm going to do here is write my switch statement. Let me get rid of the indentation here. This is just to show you a little bit of the syntactic sugar. So we're going to use the taxes example that we had, where we have an item, or you've got an item that's got a price, I don't know, $4.95, and a category. In this case, we'll say it's food. And then let me put the rules here, which was something like food is taxed at 0%. Let me see. Groceries. Oh, not groceries. Call that food. Sporting goods are taxed at 10%. And clothing is taxed at 5%. Something. And I'll even include another category to account for everything. It's taxed at 7%, right? So we've created these different tax categories for your item. So what I'm going to do is I'm going to switch on what the category is. And then my case will be these different possibilities. So the first case will be food. And I'm going to create a variable up here called tax rate and just say it's at 0 right now. So if it's food, I want to set my tax rate to 0 again. And then down here, I'll print out however much my item costs. Console.log. Total price is, I'm going to put parentheses here. Let me write this out in a way that's going to be a little more clear. Total price equals price times price plus tax rate times price. I'm going to comment this bit out real fast and write this as an if statement, and then we'll switch it over so that you guys can see the change. If category equals food, tax rate equals 0. See if this works. Probably have a bug in my code because that's a lot of code I wrote. Oh, total price is $4.95. All right. So now let me write the next bit. Else if category equals sporting goods. What's our tax rate for that? 10%. Actually, I need to do the decimal to get this math right. So let me change this to be sporting goods and test that. Ah, good. A good example. All right, I think that worked. And we have our two other cases, right? Category equals clothing. Tax rate equals 0.05. We change this to clothing and test. Bit by bit. Looking good. Otherwise, and I'm not even going to check for other, I just know that everything else will fall under other. Everything else falls under other. I don't care, so we fit in there. It doesn't matter what the other categories are, right? Okay, so we've got our little bit of logic here. Now, if I want to convert this over to a switch statement, I'll do it bit by bit again. And this is how you would do it. You say switch, you've got your condition that you're switching on. And then each one of these looks like it just has to be a constant. I can't make this a condition. So in this case, food, I need to say tax rate equals 0. Let's see if it works with food. Looked like it worked. So now I need to put another case in here. And this case is sporting goods. I'll say my tax rate with that, right, is 10%. All right, now let me test real fast that this didn't change my code with food. Wait a minute. My result with food changed when I added another case. This is one of those quirks of switch cases that make it hard to work with for people. This is one of the reasons why some people will also encourage you not to do that, is the way it works is, unlike a nice if-else, this will just cascade and keep running until you tell it to break out a little bit like a loop. So you have to put a break here to say, I'm done with this switch statement. I'm done. Don't match any other cases in here. This is the only one you're supposed to match. So now let's test it with the food. All right, we didn't break it with the food. So now let's change this to sporting goods, see what happens. It looks correct. And we'll add our other cases, but remember, always put your break. Case of clothing. And in that case, our tax rate is 5%. Make sure that didn't break our, looks like our sporting goods still works. Let's try to make this clothing. If it works. And now the nice little bit here is, this is a little bit like an else, is there's a built-in one called default, which if you didn't match any of the other cases, it will fall into this one, and that's where we can set our tax rate to be 7%. And since that's the last one, we don't have to break out because it won't, we can, but you know, it can't run anything else after that. And we can test clothing should still be what we expected, which looks right. And then, you know, anything else that we put here, we taxed at this default rate. So if we were to look at those together, in this case, the switch statement was actually more lines of code than our nested if statements. But it depends on how you feel. You could argue that this is easier to read, perhaps, right? It's a little more clear what you're checking against each time. I would say that it's in this case, it's probably a coin flip. That's another reason you probably won't see it as frequent with the switch statement. There are times when it's nice to have it. One example, but don't worry about this, is I mentioned you can match multiple, like it'll cascade through these cases. That can actually be something you intend to do in a very weird way. That's very edge casey though. I'll put it this way. If somebody puts that in code at work where I'm at, we would require them to put a comment in the code explaining why they're doing something they shouldn't be doing normally, so that the next person who looks at that code doesn't try to fix it. They would have to say like, intentionally cascading, like running multiple conditions in this switch for reason X, Y, or Z, because it's pretty odd. And somebody else would come along and say, oh, you've got a bug in your code if they didn't put that in there. But it is something you can use as a tool. So again, I'm not going to write any homework that requires you to write a switch statement. You can use if in any situation you could do with a switch statement. But it's a useful little tool in some cases. Any questions on that? All right. I don't know if I have any other little bits of syntactic sugar I wanted to introduce today. I don't think so. So the last thing, which is more homework assignment than anything else, is next class we're going to start talking about objects. That's really the last major data or type that we're going to encounter in JavaScript. And in order to start thinking about the way objects work, objects in a programming language are intended, they're not perfect analogies, but they're intended to model the concept of a real world object, like something physical, like this projector remote control is an object, or even something much simpler like this. Let me see here. I think I have like a dime. Like this dime is an object. And as a result of that, objects in programming languages are described using properties. Like, what are the properties of an object that describe an object? You know, how large is it? How wide is it? What color is it? What's the texture? What is it made out of? You know, does it have any different parts that go together to make it that are their own little objects? So what I want everyone to do, and we'll come back, this will be something that we'll do interactively in the next class. I want people to talk about what they did, is choose an object and make it something really simple, because otherwise there can be a lot of properties of it. So choose something very basic, but choose some sort of object at your home. I don't know, a pencil, a coin, a straw, you know, it could be just about anything, a ring. I'm just looking at stuff around me, a chair, and try and describe as many properties of it as you can. And do that in a way that you think would make sense in some sort of programming language. So try and be as concrete as you can be when you're thinking about the properties of it. So a chair might be really hard to describe because there's a lot of measurements, for example, of a chair. But you know, don't worry if we don't hit everything. You can also stick to just the higher level concepts, but just practice a little bit thinking about what are all the properties of an object, and what does that mean in terms of how do those properties affect the object. So next class, I want to have people, it'll probably be like a little bit of a popcorn, like what do you have and what are some of the properties that you have of your object? And that's because, again, like I was saying, in programming, a programming object is intended to be an analogy to a real world object. And so if you're thinking about real world objects first, it'll help you out a lot when you start thinking about an object in code, as opposed to thinking of it as some foreign entity like, oh, I don't understand it, it's just something I have to memorize. No, it's intended to relate to the real world in a way that helps you understand how they work. Yeah.
So the real world, like an object, like I can perform an action usually on that object or do something with it. So should we try to think about things that we can do for those objects?
I think that's something that they can definitely do, and that's something that does exist in code, to me, that's a challenging one. Like, feel free to talk about stuff that you might do. Like, you know, I mean, I have a dime, I can like flip it, for example, and lose it. But yeah, I think that's a great thing to do. So jot down different types of actions that you might take about it, or properties that it might have as a result of the state that it's in. So maybe, you know, if you choose, I don't know, bouncy ball, you know, it may have a speed as a property, right? That's something that's going on, and you may have an action that you could take against it of throw it or start, you know, move it or something. That's always a tough area for me because that's where the analogy breaks down on object-oriented programming, at least with the way that it actually ended up being implemented in most languages. Because for me, at least personally, it's hard to envision. Usually we attach those types of behaviors to an object, and you'll see a lot of this in the next class and going forward. You know, you would have, like, on a ball object, you would have a throw method, sort of like how the console has a log method that we're using all the time. It's a little weird to me because, like, the ball isn't really throwing, so why is that on the object? Really, someone's throwing the ball, which is changing some properties of it. But that's just me being pedantic, me being all ridiculous about how stuff actually works in the real world. But yeah, we'll come back, and we might even choose some of the objects that people have and use those as our examples in the class when we start talking about them and modeling properties on objects and methods on objects and how some of that stuff works. So just choose one thing and try and jot down whatever you can about it in terms of properties. There'll also be some actual coding examples. I just don't have those up yet, but I'll be adding some more stuff to the REPL site. Do you guys get any sort of notification when new assignments are added there? You get an email? Okay, I wasn't sure. So yeah, I'll be posting some more stuff on there as well. Any other thoughts or questions? All right. Be done for today.